One of the things that we like to point out is that we use very safe technology in our batteries. So our batteries are composed of cobalt-free lithium iron phosphate battery chemistry, which many of you may know is much less likely to experience fire-related problems and issues related to thermal runaway that cobalt-based chemistry can have. So essentially, we have no risk of unmitigated thermal runaway with LFP batteries. And in particular, our battery cells, our cylindrical cells, have very long lifetimes as well. We're very well tested. We're certified with UL 1642 on our cells, 1973 on our battery modules, as well as UL 9540. So UL is a private organization that does outside testing and certifications for batteries. We have done UL 9540 cell and module level tests and use those to inform our fire safety recommendations for 9540. We have UN Department of Transportation certifications as well, 3480, which allows us to ship batteries, and 38.3 on some of our special batteries that allows us to airship them. And this in particular is something that's only available on a select number of our batteries because there's a weight limit to air shipment of batteries. And I think that weight limit is 86 pounds. And by avoiding cobalt chemistry, we're really avoiding some of the problems associated with mining cobalt. Typically, these problems occur in Africa, where most of the cobalt mining is done. I have a fairly intimate connection with Africa, and I lived there for 4 years, and my wife is from there. And mining does cause problems there. So again, we're avoiding that by, instead of using cobalt, we are using iron in the cathode of our batteries. And we've been doing that for a long time, ever since inception in 2010. We are a proven manufacturer of batteries. We do our factory is located here in Oxnard, California. We do our testing, we do our fabrication here in Oxnard, and we ship from California. We've been deployed in over 45 countries. We have over 250 megawatt hours installed now. These numbers keep going up, so that number might be a little bit dated. We also have a history of being tested and validated by the US Army as well as the Marine Corps. So we provided some initial solutions for them when they were originally switching from lead acid batteries into lithium. They had concerns about the safety of lithium, and we were able to answer those concerns, as well as prove through rigorous testing that some lithium chemistries are extremely safe, right? LFP is a great example of an extremely safe lithium chemistry. And again, as I mentioned, we have special permission by the FAA to airship globally. That's only for select models based on weight limitations. We also have a business model that demonstrates social impact, and we give back. So we do donations to different projects. So we have a program called the IDEA program. And so if you have an excellent candidate for a nonprofit type project, we might be able to provide some donations. So consider that. We offer simple solutions. So one of the themes with SimpliPhi Power is to provide easy to use solutions. So we have easy to use solutions for many of your energy storage needs. Particularly, we have a product line that's excellent for replacing existing lead acid battery banks. And we have outdoor rated products. We have plug and play type products like our access cabinets that have everything hooked up and wired. All you have to do is drop the batteries in and connect it to your loads panels. We have designed our batteries to last as long as possible. So really one of the themes, we are not the cheapest battery on the market, but we emphasize quality and longevity of our products. We have a 10-year unlimited cycle warranty with 100% depth of discharge, and almost no other battery company can say that. We stack up pretty well against the competition by offering a really solid warranty, and we stand behind that warranty. And your warranty is from Briggs and Stratton, a longtime US company, 110 years old. So we're creating savings for your customers on their energy bills, and we can do that through helping them with time of use, peak shaving, demand charge management, And as NEM3 takes over here in California, people are getting less and less back from the utility companies. Energy storage is going to becoming a bigger and bigger component to making your system cost effective for your customers. So as I mentioned, we started as optimized energy storage back in 2010. So we've got 13 years now of lithium iron phosphate, battery history, development, intellectual property, etc. We've been developing for this whole time and getting better and better. We have a lot of products in the field that are outliving their warranties and still being used today from those original days as optimized energy storage. What you're seeing in 2011 and 2012 are some solutions that we provided for mobile solutions for the US military. We expanded the product lineup in 2013 and 14 to provide mobile solutions, film and broadcast industry, etc. We relaunched in 2015 as SimpliPhi Power, introducing our access cabinet, our outdoor rated battery cabinets, as well as cabinets integrated with inverters. In 2017, we started ramping up production. We developed a high voltage lineup, which I'll talk a little bit about today. And then in late 2021, SimpliPhi Batteries, SimpliPhi Power was purchased by Briggs and Stratton. And so we are now part of the Briggs and Stratton Energy Solutions division, which has really offered SimpliPhi a larger product development sector, as well as the history and the experience of Briggs and Stratton. So we've released a new product. We have this fully integrated ESS system, which comes with monitoring, remote configuration, an app to allow configuration and monitoring by installers, as well as an inverter and an outdoor rated battery, which is what you're seeing in the top right of the screen. We, of course, still have our full product lineup of SimpliPhi batteries, and we'll be talking about the BMS units inside those. And we have containerized solutions. So if you have a very large product, we have a whole high voltage division, large projects division that you might wish to be in contact with. And if you do, send me an email and I will connect you with them. So as I mentioned, we've got a growing global footprint. We've got over 45 distributors worldwide, and we're being installed in many different locations. Our big markets, of course, are the US and the Caribbean, where we compete very well by offering a very reliable product. So some of the problems you might know about, people are well aware that the energy grid has become less and less stable. Just a month ago in California, where I live, we had problems with flooding, and we lost electricity because of that. But it's not just weather-related events as well, right? There are strains on electricity, partly because of the prices as well, right? And so a lot of developing countries around the world will even cycle their electricity, and so you have rolling blackouts, and I experienced those often when I lived in West Africa. There's electricity prices are rising, and it makes it very hard. I know in Puerto Rico, the electricity costs, we're looking at 60 cents or more per kilowatt hour. I am being charged 40-some cents per kilowatt hour for my electricity here in California. So costs have been growing, and diesel generated power, of course, with offering backup through generators as the diesel prices have risen. So as the cost of generating kilowatt hours with diesel engines. You also have the downside that there's a lot of inefficiency when you're operating diesel, that and noise and regulations about use of generators. Failing infrastructure has caused many problems with the grid, right? So the grid is aging, and if local electricity companies are not upgrading components in the grid, we have more frequent outages, and we've noticed those in California with having fires caused by PG&E, and you may have noticed some of those issues in your states as well. Of course, we shouldn't leave out that there are many who want to decarbonize our energy sources. We want to have clean energy, right? Clean energy that is reliable, and that's important, right? That reliability. And if you do not have storage, then you're really not going to have reliable access to clean energy. So storage is highly needed. And of course, we cannot forget, right, that the whole country is electrifying. There's a huge number of electric vehicles that I see on the road daily, and that number is only growing across the world as well. But I don't have to sell you on this. I'll mention just briefly for your customers. Some customers might be on a managed rate plan in which that plan depends on the peak energy use, right? And so there are tiered cutoffs for the amount of power that can be consumed. And so if your power needs ever exceed certain rates, you get bumped into higher electricity rates. And so if you exceed a certain number of kilowatts, you could be charged higher on your entire bill. And so by having a backup power source where you have energy stored, you can shave off those peak needs. So you might have a factory, a small factory that's running production, but when you're running those welders, some of your energy could come from backup storage just to shave off those peaks and prevent you from being bumped into higher tiers for cost. There are time of use rates as well. So I'm on a time of use rate here in California where I get charged differently depending on when I'm consuming the electricity. And so if you want to utilize energy utilize energy from your backup storage system at those high cost rates, those times of high cost rates, then you can do so with backup. And of course, we all know that most renewable energy is coming from photovoltaic panels, which generate their electricity during the day, but many people want to use that in the evening when they come home from work. So as I mentioned, there are many different types of lithium batteries, and a lot of consumers don't know that, right? There's a big difference between the batteries that might be in your power tools, which are typically NMC batteries that can be in your car, batteries that might be used in drones where weight is an essential and possibly the most important consideration, and batteries that are used for your home. So my opinion is, because of the safety of lithium iron phosphate, the only suitable battery for your home should be LFP, lithium iron phosphate battery. It is a little bit heavier, so you have a little bit more weight, but for home considerations, that's really not that important. It's when you have those ultra light mobile applications that you might want to choose a cobalt-based chemistry. The other reason, of course, is that safety factor that I mentioned. But there are also a lot of different kinds of LFP batteries themselves. They're made up of cells, and those cells can be different types. So pouch cells are the cheapest, but they're also the shortest lived and the least safe. They're easily punctured. They're really just foil wrapped jelly rolls, which are an organic electrolyte sandwiched between a cathode and an anode, the positive and negative sides of the battery. And so pouch cells are often used in really low cost mobile applications. You might see these in things like headphones, etc. I have seen pouch cells being offered for home battery backup, and yes, it's a very low cost, but at a high cost in terms of safety and longevity. Some reasons for this is those pouch cells expand and contract often as they heat up and cool down, as batteries naturally do when they're cycling. And that expansion and contraction results in an eventual degradation, a separation of the layers, and pouch cells are therefore the least long-lived. A second, a much better battery, but slightly less expensive battery than cylindrical cells is one composed out of prismatic cells. And prismatic cells are typically very large cells. They have a fairly rigid casing. They're a decent choice for home battery backup. They're not quite as expensive as cylindrical based cells, but they're also not quite as good. So they have some downsides to them, and that's one of the downsides, and one of the reasons we don't use them is that they're a very large cell and heat management is more difficult. And because heat management is more difficult, that means that the battery is also a little bit less lived and you can't discharge it quite as quickly. So these very large prismatic cells can be used to produce big batteries with high capacities at lower costs, but we don't do that. Again, our target market is a top of the line battery. And so we use cylindrical cells, and what's inside a cylindrical cell, so you can think of What's inside of our batteries are these cylindrical cells that look, you can think of them kind of like the AA, AAA batteries that you've seen before. And so our cells are composed of hundreds of 32700 LFP battery cells. These are steel cased cells which have rolls inside them, and those rolls contain an electrolyte, an organic electrolyte, and they're hermetically sealed, which means the steel case is sealed off from the environment, so you have no contact with oxygen, etc. And so we use cylindrical cells, we use LFP battery chemistry, and that's how we make a premium battery that can last for 10,000 cycles. And so 10,000 cycles, if you cycle daily, would be 27 years, right? Over 27 years. So we guarantee that no matter how many cycles you can get in and no matter how deeply you discharge the battery, we guarantee all of our batteries for 10 years, unlimited number of cycles. So as I mentioned, we combine these hermetically sealed LFP cells. We have a premium manufacturer that we've been using for a very long time, that we've gotten better and better quality cells from over the years, and we're really confident that our batteries will last well. But you can't make a battery out of just a single battery cell. If you do, for LFP, they'll have a nominal voltage of 3.2 volts. And I think for most of the cobalt-based chemistries, it's somewhere around 3.8 volts. But what nominal voltage means, it just means when the battery's at a 50% state of charge, the voltage reading on the battery would be 3.2 volts. So our batteries, in order to get up to 48 volts, right, we need to have stacks of cells arranged in parallel in series. And so if we have 16 stacks in series, those stacks would produce a 48 volt battery. Now, when you have many cells in parallel in series, you have to be very careful that you're balancing those cells, and we'll talk a little bit about that. So inside these battery packs, we have stacks of cells that are joined in parallel, and those stacks themselves are joined in series, and we need something to control the balancing of those cells. So that's what this presentation is all about, understanding something called the battery management system, which is known as a BMS. So as I mentioned, our batteries, our battery modules, the complete battery itself, what you think of as a battery, is composed of very many cells. And these cells have a management system inside them called a BMS, so battery management system. We have a proprietary BMS. We've had a manufacturer here in California producing that for a long time. We've refined and refined this and have very good software in it that we're quite confident about. What is a BMS? There's an example of a cheap BMS on the bottom right side of the screen. The BMS you can think of, I guess, as the brain of the battery cell or of the battery module. It's what keeps track and really protects the battery from unsafe operating conditions. It can also, in the case of some BMSs, monitor environmental and system-based conditions, maybe such as temperature. Of course, the outgoing amperage of the battery itself, and the state of balance of the stacks inside that battery. And it can provide programmable communications as well. So communications allow the battery to talk to the inverter, to talk to charge controllers, to talk to even just battery monitors, equipment outside, let it know the state of health, etc. And some BMSs, and I'm going to talk to you about our more advanced BMS systems, can control thermal management systems, which can even regulate coolant. In the case of batteries, typically for cars, will have a coolant or even a heating system to get those cells at the operating characteristics. But the main purpose of a BMS is to protect the battery from damage and to ensure that the battery has access to its full capacity. So, many people are familiar with deep cycle lead acid batteries. Shown there in the top right is an example of a 6-volt lead acid battery that's 3 cells joined together in series. Most lead acid batteries do not have a BMS, do not have an integrated circuit breaker, right? They are much lower cost, but you don't get as much out of them. right? So often lead acid batteries are rated at a C/20 discharge rate. That means if you took the battery and very slowly discharged it over a course of 20 hours, how much total energy would you get out of it? The faster you take energy out of a battery, the more energy you actually lose in the form of generation of heat. And most of these batteries, you don't want to discharge, most of the lead acid batteries, you don't want to discharge more than a 50% state of charge. So the rated battery capacities for lead acid batteries are really a little bit misleading, right? And if you look over the course of a lifetime, a lithium battery, even though it's a greater upfront cost, if you look at the number of cycles, the depth of discharge you get out of the battery, 100% depth of discharge, right? You can get a lot more out of a lithium ion battery. And if you look at the levelized cost of energy, that kind of full amount you pay per kilowatt hour stored, if you add it up over all the cycles, you're really about half the cost when you look at a lithium battery like our SimpliPhi battery that's there on the screen. Not only that, right? There are installation costs that you have to take into consideration as well. And lead acid batteries are really not the way to go anymore. Lithium batteries have gotten better and better, and the BMS units inside lithium batteries ensures that we can use the full capacity of the battery. That's done by balancing, and we'll talk about that. It protects the battery from abuse, and it helps prevent something called thermal runaway, which is when a battery, if it gets overheated for any reason, maybe there's an external fire, or maybe the system is inside of a vehicle that has a crash, thermal runaway can result in rapid production of heat, which can cause the cells to off-gas. So it can occur, but BMS can help prevent that. So here's a simplified diagram of a BMS, and this is obviously not the BMS that we have inside of our systems, but this is a simplified diagram of what a BMS might look like. It shows here the connection to the negative terminal, so that's the common minus on your BMS unit. And it also has a connection to the battery side, and then we run through our cells. And as we go through our cells, we have them arranged in series. So this is an example of a 4S. And the 4S here just means 4 in series. Now there are 8 cells that are there, but they are joined in sets of 2, right? And so 4S means 4 sets of series. And then what you see coming out down here are the balancing wires. And so this is common. This is only a 12-volt system if we're looking at LFP cells. So it's a 12-volt battery, which is a 4S unit. So what does the battery do? The battery cannot, many people have misconceptions about what the BMS can do. The battery management system cannot throttle the current back, right? It has no means of saying, hey, I'm going to limit my current to this value. One thing it can do is open or close a contactor, which allows the battery to isolate itself from an unsafe system, but it doesn't have individual controls. There's no mechanism by which the battery can do that. So I'll talk a little bit about how battery management systems work. Analog BMSs are really the cheapest type of BMS, right? So for a low-cost battery system, you might have an analog BMS. It's programmed during manufacturing. Typically, the circuit board doesn't allow for adjustability. It doesn't allow for response. And it's just relying on some key components to take actions like balancing the cells and preventing overcurrent. Here's an example of a BMS that you can buy online. I think this one is from overkillsolar.com. I think I bought one of these a couple of years ago or a year ago. And so this is a 16S, and so 16 sets of cells in series to produce 48 volts for LFP. These are programmable, and they may even be programmable in the field. They might and might not. This one has a Bluetooth dongle hanging off the side of it. It has temperature sensors that are here that could be integrated into the battery. And then these are balancing wires here on the bottom. Your connections to your battery and your cells are here. And so this particular one allows you to transmit data. It's a digital BMS. And it gives you an output, and so you can look at what's happening to your battery, how your battery is behaving over time. So we have both low voltage and high voltage BMS units as well. So why can we not stack our low voltage batteries in series, right? You cannot take two 24-volt SimpliPhi batteries, put them in series and make a 48-volt battery, or three and make a 72-volt battery. We never do that, right? And the reason is that any individual battery in a chain, in a series chain, can disrupt the others from performing, right? Balance is key. So we only ever install our batteries in parallel. On the right side of the screen, I'm showing you a high voltage battery. And this high voltage battery contains what's called a stack controller. And this, I'm sorry, I accidentally skipped forward there. The stack controller is controlling the batteries as well as taking care of the balancing. And so stack controllers are typically basically the BMS unit for very high voltage solutions. And we have a whole set of batteries like this that come in either 48 or 24-volt blocks. So why are battery management systems important, and how do they cell balance? How do they protect the battery cells? Well, cell balancing is done with small currents, and it's really done at the end of the charging cycle, mostly at the end of the charging cycle. So here on the right side is an example of passive cell balancing. So passive cell balancing, basically you can imagine when a battery is charging, charge is being forced onto the battery cells, right? And you'd have a current flowing in this direction during a charging cycle. If one of those battery cells ends up being higher than the other battery cells and stops charging, right? And a passive charging system can allow current to flow through a resistive circuit. And typically these are very large resistances compared to the individual internal resistance of the cells. And so you can have a little bit of current flow through this resistor. The capacitor is here just to eliminate rapid fluctuations. It's there kind of as a filter to prevent spikes in current as this control system, this diode system is open and closed. And so if this first cell was fully charged, current could flow through this resistive circuit, through this gate, and then cells 2, 3, and 4 could continue to charge, etc. If any other cell it slows down its charging during the charging cycle, it could be bypassed through this resistive circuit. The downside of this is that, of course, if you're having charge flow through a resistor, you're producing heat and it's inefficient. So an alternative way to do this is to do it with active cell balancing. And one of the things that is done with active cell balancing, instead of wasting energy by running through a resistive circuit, a BMS can control an active cell balancer through a series of switches, which can actually take current from one cell, if it's at a higher state of charge than the others, charge a capacitor, and through this switching circuit, use that charge to charge up a different cell in the circuit. There are a lot of advantages to these types of circuits, active cell balancing. And of course, they're much more efficient and better overall performance. So our BMS units, of course, have active cell balancing within them. We also have advanced BMS units that offer communication. And so you can get some level of protection for your battery through a closed loop communication system. So some batteries, like our SimpliPhi battery, our SimpliPhi 4.98 kilowatt hour battery, include an advanced communication system as part of the BMS. And so the BMS is programmable. There's a lot of data that can be read through these communications wires. And I'm pointing this out, the wiring out here, in case you're installing one of our communicating batteries, just to mention that there's this terminating resistor. So basically this is closed loop communications. The BMS units are connected from one battery to the next in this form of daisy chain, right? So battery number 1 is connected to battery number 2. Battery number 2 is connected to battery number 3 to number 4, etc. But the end of the chain, there's a terminating resistor. It looks almost like a little USB drive, and you can see it here in the picture. One of the problems we get in tech support is people forget to install that or lose that, and the communication system will not function properly if those terminating resistors are not there. So our batteries with advanced communications allow the battery to communicate information about state of health, state of charge, temperature in different locations within the battery, how quickly the battery wants to be charged, how quickly it can be discharged, and it can report all this information up to other equipment systems such as inverters or charge controllers. So programming. If you're using a battery without communications, it is very important to program system equipment properly. And what this means is that you have to pay attention to the capabilities of the battery. So, for example, the BMS system is really just there as a fail-safe, right? There is a breaker installed on every one of our SimpliPhi batteries, right? And that breaker can be tripped if too much current is there. The BMS can also open circuit if the inverter is demanding too much current. But as I mentioned, there is no way for the battery management system to turn down the output of current that is there. If a component is demanding or supplying a certain amount of current to a battery, the battery will provide it, right? Unless, right, designed properly, unless the inverter is programmed alternatively, right? So that means for our batteries, there's a 2-to-1 ratio. What do we mean by a 2-to-1 ratio? Our batteries are all rated at a C/2 discharge rate. And what that means is the battery can discharge its entire capacity in 2 hours. C/2, the capacity per 2 hours, right? A C/1 discharge rate would mean the battery can discharge it in a single hour without damage, right? A C/20 discharge rate, which is typically the discharge rate used for lead acid testing, right, would mean that the lead acid battery would discharge over 20 hours. Okay? If you discharge too fast, you produce too much heat inside the battery, and too much heat inside the battery can damage the internals of the cells themselves. Right? There's an organic electrolyte in there that can be vaporized if it's heated too high. So C/2, or the 2-to-1 ratio, the C/2 rating means if we have a 4.98 or a 5 kilowatt hour battery, C/2 would mean that the output power of that battery, so the capacity of the battery is 5 kilowatt hours, the output capacity would be 2.5 kilowatts, right? Can discharge a total of 5 kilowatt hours out of a battery. You can get, if it takes 2 hours to do that, you need 2.5 kilowatts for 2 hours. What's shown on the screen here is a Phi battery, and that Phi battery has a capacity of 3.8 kilowatts. That means the output power that this battery can supply continuously is 1.9 kilowatts. Now, our batteries are all capable of surging, but only for a short time. That Phi battery that's there on the screen, if we look at a C/2 discharge rate, that battery as a 48-volt battery is rated at 75 amps. C/2 would be half of that, or 37.5 continuous amps. The battery can surge for 10 minutes at 80 amps, but everything should be programmed so that this battery is continuous discharge rate is 37.5. You can add external equipment to monitor batteries. Here's an example of a BMV 712. That's a Bluetooth-enabled smart battery meter produced by Victron. It has, you can get a temperature monitor here. Unfortunately, this temperature monitor really monitors the temperature on the outside of the battery modules, right? And so it's if you're really looking for better control, you want to use a communicating battery, which our batteries monitor the stacks in many different places to ascertain the temperature. This is a programmable charge controller. Almost all inverters and charge controllers, new ones, are programmable. Old ones might not be, so you want to make sure before you slip a Phi battery in place of a lead acid bank that you make sure that the equipment that's there is capable of charging to the right specifications. That means we have to pay attention to things like low battery cutout. A 48-volt LFP battery is actually at 100% state of discharge at 48 volts, right? The battery actually holds typically at 100% state of charge closer to 53.5 to 54 volts. And that voltage drops down as the battery is discharged. We want to make sure that we pay attention to the charging voltages, right? So the BMS, right, is expecting different voltages for the charging cycle, and that helps to maintain the health of the battery. There's a bulk charge is when you're charging at a constant current at the beginning of a charging cycle. Absorbed charge is when the battery is left at that voltage for a certain amount of time. For our batteries, it's 10 minutes at 56 volts. And then float charging, you really don't need to do this for lithium batteries. Lead acid batteries had a high self-discharge rate. And so typically those batteries would be floated, right? You know, if you leave your car for a month, that the battery very well might be fully depleted when you go to start your car. Well, a lithium battery, LFP batteries, have a very low discharge rate, on the order of 1% if you let it sit for a month. So floating is not recommended. I guess you can do it. We recommend it at 54 volts if you're going to do it at all. And I would only do that if you have a free source of energy, such as a renewable, like a wind or solar that's providing. Want to make sure that you program in the max current, right? And it's 37.5 volts per battery for the PHIs. And the max discharge current is the same, right? So it's per battery. So if you have 10 batteries, you could get 375 amps out of your bank. Cold temperatures are an important consideration for lithium batteries, and this is true for all lithium batteries. And the reason for this has to do with the movement of the lithium ions themselves into the anode of the battery, which is made out of graphite. And at low temperatures, the process of the lithium getting into the graphite is slowed down. The process is called intercalation, and it slows down rapidly at low temperatures. So it's recommended not to be charging a battery. The batteries can discharge at lower temperatures, but not to be charging a battery at temperatures below 0 degrees Celsius. Now remember, that's the battery cell temperature we're talking about. And typically the battery cell temperatures are above ambient temperatures because batteries produce a little bit of heat as they charge and discharge. One solution for this, of course, is just to keep your batteries housed. So 907 has submitted a picture to us, allowed us to use this picture. In the background, you can see a shed, and the batteries are stored inside the shed. And that helps to insulate the batteries from the environment, which might change temperature very rapidly overnight, and it slows down that overall temperature range. Additionally, we have solutions for our lithium batteries, which we can have this heating pad installed, which communicates with our battery management system, and it allows it to turn on and turn off the heating pad as needed. If you're looking for a solution like this for cold environments, contact us. These are special order, but we have this equipment available that allows our batteries to cycle in low temperature environments. The SimpliPhi and SimpliPhi BMS batteries are 3.8 SimpliPhi and our 4.98 outdoor rated SimpliPhi batteries offer advanced communications. This is closed loop. So the BMS inside these batteries has closed loop communications, which allows the batteries to communicate with each other, as well as to communicate with external equipment, such as a monitor or an inverter or some type of charge controller. And so what I'm showing you here is the wiring here. Most of the crucial settings are automatically already programmed into the BMS. And so our BMS comes with proprietary software that includes software telling inverters how to talk to our batteries and telling the batteries what settings we want them to operate on at. So it's pretty nice when you're going to hook up a system with comms that the battery themselves, when you hook up the comms properly, tells the inverter what settings it wants. And our batteries currently communicate well with SolarX. We did have communication with SMA, but there's a firmware update from them that's caused some problems. And so we're resolving that right now. Our batteries also communicate well with our own inverter, but you want to make sure to have that terminating resistor. So all these batteries are daisy chained in series with the communications from one battery to the next. And then there's a third port on the BMS. And that output port there, any battery in the bank, it doesn't have to be the end one, can be hooked up to an inverter or monitor, etc., through the device port there. So these batteries, the SimpliPhi battery and the SimpliPhi battery with the advanced communication system, even though it's recommended that you don't charge lithium batteries below 32 Fahrenheit, these batteries allow you to do that. They just reduce the rate of charge to prevent problems with intercalation. And so you can see that at very low temperatures, between -20 and -10 we slow down the charging to just 1 amp. That's only about 3% of the typical charging capacity of the battery, right? And -10 to 0 Celsius, we're about 10% of the charging rate. And so the SimpliPhi BMS unit, right, controls the charging rate to make sure that the battery's state of health is maintained. And so even though we say that the charging temp is this, it's actually slightly elevated, so it's slightly larger charging range. And then the discharge range is not as much affected by temperature, because then the lithium ions are going the other direction. So the operating temperature is what we really mean is the discharge, the time when the battery's providing power to the inverter and supplying loads. So we have a number of different products, and we have a whole line of Phi batteries, including our batteries with ABS casing. We've got small 12-volt, 24-volt batteries that are nice for mobile applications. The Phi batteries themselves are great lead acid replacements, where you're going to get a long lifetime and a long substantial warranty out of your batteries, but they don't offer the communications that many people are coming to expect of batteries and battery backup systems now. So for that, we recommend using a battery like our SimpliPhi or our SimpliPhi battery. If you need an outdoor rated battery, our SimpliPhi battery is a good choice. These batteries have the closed loop communications that I've talked about. They have auto-populated set points. So if you hook 4 of these batteries up in a bank, the communications, the battery's BMS system will automatically detect other batteries in the bank, and it will know how many batteries are there. It will know how to set the parameters inside the inverters and the charge controllers. So this advanced integration works very well with solar inverters, with the Briggs and Stratton inverter, and you get automatically populated set points. Get high level protection as well. The battery management system can open and close circuit to protect the battery in the event of ultra high temperatures or ultra low temperatures as well. And it also outputs very accurate, high precision state of charge, voltage, charge and discharge rate information from the BMS. It's flexible sizing is a key to SimpliPhi batteries, right? A lot of other companies come out and just come out with a 13 kilowatt hour battery bank. And if you wanted to add just a little bit more, if you needed just a little bit more time, you can only operate in chunks of 13 kilowatt hours, right? Well, our batteries come in smaller building blocks, and so you can really customize this from a very small system up to a very large system. You can put up to 72 of these batteries in parallel. And with our 5 kilowatt hour battery bank, right, that's 350 kilowatt hours of backup. That's huge. Most people don't need anything near that, but getting 15 might be nice. And if you're having building blocks that are 13 kilowatt hours, it's really hard to do that, right? 15, 18. So by using a smaller building block, this is essentially a 4 kilowatt hour battery, 3.87, right? You can get very close to the needs of your customer. And the other nice thing about this smaller scaling factor is that the batteries, you can start off with a couple of batteries, and as maybe the customer budget grows, you can add batteries in the future. If you've got a very big system, I would never recommend that you actually put 72 of the 4.98 kilowatt hour batteries in series. You could do it, in parallel you could do it, but you wouldn't want to do it. You would want to go with a high voltage solution. So we have our high voltage solutions. This is a 48 volt high voltage battery stack. So these high voltage stacks will go all the way up to 1180 volts, and we typically can pair these with 3-phase inverters to suit your needs. So if you have a large project, contact us. We have containerized solutions where we can put these straight into shipping containers or develop some containment method for you. We have battery monitoring, and of course you're getting the high quality SimpliPhi cells in there as well. So choosing the right battery for your customer, choosing the right setup for your customer. You know, if you're new to installing these systems, a system like this where we've got a solar inverter paired with 6 batteries, everything comes with this. It's really kind of a plug and play solution. It's UL 9540 certified. ready to get your tax rebates, etc. This is called an access cabinet, and we have this one here paired with a Solarc. I'm not sure whether that's an 8K or 12K. If you're just looking for batteries, right? Our batteries are some of the top of the line batteries, and we've got the Phi battery here. These batteries can come with these wall brackets if you need them. A lot of customers will have designed their own shelving, and these batteries can even just sit on the floor. If you're looking for battery cabinets, though, we have a large selection. We have something called the Boss cabinet, which looks like this. It just has 4 shelves of batteries offering 46 kilowatt hours of storage in an outdoor rated enclosure. So this solution, the access cabinet or the Boss cabinets, can be mounted outdoors. If you need something that can be mounted outdoors, we also have 4.98 kilowatt hour, the large SimpliPhi battery here. That's an outdoor rated battery. It's got still that advanced communication, closed loop communication, BMS built into it. We also have smaller batteries available as well. We have some mobile solutions. These are good solutions for contractors. Maybe the electricity for a job site has to be out, but you're in an area where generators are not allowed. You could use a solution like this, run your tools. It's got a MagnaSign inverter in there and a charge controller built in. And as I mentioned, we've got high voltage products as well as containerized solutions for large scale products. So as I close the training here, I'm going to come to the questions, so feel free to pop them into the Q&A. I wanted to point out some things about our website because I also work on technical support for SimpliPhi, and we got a lot of questions that'll come in, and I want to point out that our website is a very good resource. We have our installation manuals here. There's a link here to register your warranties, so we encourage you, after you've done a job for a customer, to come in here and register their warranty. We honor it either way, but it's very good for your customers to know that you've taken care of them and registered that warranty. And there's some benefits to doing this warranty registration that I'm going to talk about in just a little bit. We have this installer qualification program, and so we have an elite installer program. We'll put you on our map. If people are looking to buy SimpliPhi batteries, we'll put your installation company up here on where to buy our batteries. And so I'm going to talk to you about that. There's a $1,000 bonus right now, which is huge for signing up to be an authorized installer. And it's a pretty easy process to become an authorized installer with our company. We've got a training calendar here as well. And so if you're interested in more trainings, we've got trainings like environmental considerations. So you're doing a hot temperature or a cold temperature installation, you might want to attend something like that. We've got some other trainings coming up, but we'll be at the NABCEP conference as well. In St. Louis here just in a couple of weeks. I wanted to point out the installation manuals. They're here as well as integration guides. So let's suppose you're using our batteries with a Solarc or a Sunny Island. We have manuals that tell you how to adjust the set points for other people's equipment. So we've for a long time been inverter agnostic, meaning our batteries can be used with anybody else's inverters. And we show you how to program their inverters. So you've got a question about programming a Solarc, you might want to check our integration guides before you go to their website. We've got how-to videos up on the website as well. There's more training, a lot more training. So you probably know that Briggs and Stratton has been a generator producer for a long time. They started by making the engine for Generac 70 years ago now, I guess, in the 1950s. Generac and Briggs and Stratton went their separate ways, and Briggs makes their own whole lineup of generators. So we have some generator trainings as well as battery backups, as well as integrated solutions in which you can use both generators and batteries at the same time, which allows you a little bit more efficient use of the diesel fuel. So if you would like to look at the trainings that we have online, we have trainings where they aren't live. You don't have to meet me at a specific time. You can go to gobluevolt.com/learnbriggs. And so you'll be getting a copy of this presentation. So that link will be there. You could also just text the word learn to 33988 and it'll send you a text with the link as well. So I want to mention just for 1 second, if you're an installer, to consider joining our Elite Installer program. Our Elite Installer program has some benefits. One, we give you $25 cash back per battery installed. So if you do a system where you install 10 batteries, submit a warranty, and we will send you a $250 check if you're one of our elite installers who sign up for this program. So as I mentioned, right now we have a $1,000 sign up bonus for your first system installed. So if you sign up for our Elite Installer program, there's a link I'm going to show you on the last page of this training. If you sign up for this elite installer program, install a single system. It can even just be a single battery, right? Submit that warranty, and we'll send you a $1,000 check. So it's a pretty good offer right now for joining as an elite installer with SimpliPhi. So this is the end of the training. I want to thank you for your attention. I'm going to jump into the Q&A. My email is there, training@simpliphipower.com. If you're needing NABCEP certificate for this training today, please send me an email. Tell me how you want your name to appear on that certificate. So make sure it's the same way that you're registered with NABCEP. I'm going to jump into the Q&A right now. And one more thing to point out is if you're interested in that sign-up bonus, that $1,000 sign-up bonus for becoming an authorized Briggs and Stratton battery installer, the link at the very top of our page in purple, it says installer sign-up bonus. Go to that, plug in a little bit of information about your company, complete a training, do an install. Training's short, right? It's a 20-question quiz, pretty easy to get through. All right, so let me jump into Q&A. Curtis writes, is it easier on the battery, and would I expect more cycles if I limit charge and discharge amperage to 80% of the C/2? Kurt, I guess it would be a little bit easier on the battery to limit the current rating to only 80% of the capacity, but that C/2 discharge rate is fairly conservative. In fact, our batteries can charge and discharge at a rate of C for 10 minutes. The C/2 is really there to protect against the batteries getting discharging too fast and creating too much heat. And so if you're not discharging for too long, then there shouldn't really be an issue. So you can do it. It might have a small impact on the lifetime of the batteries, but for the most part, the C/2 should be just fine. Bob writes, we will be installing 96 Phi 3.8 Ms, that M stands for metal case, everyone, 24-volt batteries in parallel, no advanced BMS system, and Victron Quattro inverters. How do you suggest we monitor the batteries? So that's a great question. So there are a number of different monitoring options. Since you have so many batteries, I'm going to recommend that you use the NSR gateway. So that's the New Sun Road gateway, and that'll allow you to get information from the batteries. You could also use the Victron 712, BMV 712 to monitor. And some inverters will have the monitoring capabilities there as well. Good question, Bob. And if you want more information about monitoring, send us an email to training@simpliphipower.com. We'll get back to you. Eric writes, for overall system safety, can the BMS system temperature monitoring output a signal indicating that internal battery temperature is too high, either due to external heat or internal failure? This signal could be used in a building safety system to indicate a problem that needs to be addressed or indicate a failure in process. Absolutely, Eric. Our SimpliPhi and our SimpliPhi batteries and our access cabinets come with the ability to output temperature, and that data is readily available from the communicating batteries from the BMS and using the closed loop communications. Additionally, we have, so as an example of what you're indicating here, we have solutions that are already approved in New York City. So the New York City Fire Department, when you're installing batteries in high-rise buildings, right, it's a very important safety consideration. And so we're one of just a few battery companies that's approved by the Fire Department of New York City, and we have some solutions already developed like this. So if you're needing special equipment like that for monitoring, let us know. We have a solution for you already that's designed so you wouldn't have to redesign something on your own. So good question. Matthew writes, you suggested that you could start with a fewer number of batteries due to budget limitations and then add more as the customer budget allows. I thought that adding more batteries to an existing battery installation after a couple of years was a high risk option. It's a good question, Matthew. And the answer is, yeah, after about 4 or 5 years, you don't want to add more batteries to a bank. After 1 or 2 years, there's very little risk. And why is this the case? As batteries age, the internal resistance of the cells goes up. And so let's suppose we just had a single battery, but it was a very old battery. It'd been around for 12 years, and it's a 48 volt 16S battery, right? Meaning 16 cells in series. But after many years of operation, after 12 years of operation, the internal resistance has gone up. There's less lithium. The electrolyte has decayed a little bit, right? And so the internal resistance is higher. So that means if we put a brand new battery with very low internal resistance, when those batteries are being demanded to output power, the newer battery is taking more of the load on. This is less of a consideration if you have a big bank and you're just considering adding a couple of batteries. But if you have a very small bank where you're loading near peak, it's not really a good idea to add additional batteries after about 4 years or so. So if you have a specific question about that, you can call us. We can run it by our chief engineer and talk to him about whether or not it'd be a good idea. So yes, good point. After a number of years, you don't want to add many. James writes, can the SimpliPhi battery be used with a solar edge inverter? Yes, we can use the Phi batteries with solar edge. Unfortunately, right now, the communicating batteries, they can be used with the solar edge, but the communications compatibility is not there yet for solar edge with our SimpliPhi and with our SimpliPhi batteries. And Eric writes, has the new SimpliPhi ESS system been tested with UL 9540A test protocol? Answer is yes, that test is complete. Has the new SimpliPhi ESS system received UL 9540 certification yet? And the answer is no, we expect that in the next week or so. And so we're still working on that, that certification, although the 9540A test results came out very well. And so we're expecting the certification to go very smoothly. Kiran writes, is there any modeling to size the battery for outdoor application at cold weather? I'm not sure. We were on a call yesterday with Open Solar, and they have modeling equipment, but I'm not sure if there's modeling for outdoor applications. And so specifically, you're asking about cold weather, in which we recommend a decreased charge rate. So we don't have any kind of prepackaged modeling for cold weather. And remember, when you're talking about temperature and doing your modeling, what we are talking about is the cell temperature, which is typically elevated above the ambient temperature. But if you have questions, we'd be happy to help you out, both through our engineering department and through our technical support department. You can give us a call at 805-640-6700, extension number 1. There's no hold, we'll pick right up. So ask us a question there if you need to. And somebody else writes, I have a client that has a system with N-phase micros. Is there a way to install your batteries here? The answer is yes, but to be honest, I wouldn't recommend it. Okay, so the N-phase micro inverters are really probably better paired with N-phase batteries. And I say that just to be completely honest. You can certainly do it, but you need to take the AC signal coming off of the solar panels, those microinverters, and convert that back to a DC voltage using an inverter. So there are plenty of inverters that'll do this, inverters, charge controllers. And yes, it's possible to do. However, I would probably just recommend sticking with the N-phase battery that's an AC battery. And when I say it's an AC battery, I mean it's got that inversion charge controller built into it. But certainly I've seen people do it with our batteries with Solar Edge, with the microinverters, etc. N-phase is a little tricky because they try to, at least with the IQ8s, I think they really try to limit how you couple to them. And so you might have some problems if you try kind of a non-standard solution. So that's the end of the questions. I want to thank you for your time. I hope you've learned something. And if you're looking for NABCEP credits, please go ahead and send me an email, training@simpliphipower.com. Let me know what your name needs to be on the certificate. Thank you one more time. Have a great day. Contact us if you need any help.